I'd like to go over how to calculate your tabular summaries from your analysis. Here I have a flowchart in a model builder model of the final steps of my analysis. And you can see here I have the net rainfall that we had you calculate a couple of weeks ago and again last week. And then we have the surface absorption, that maximum absorption that I had you calculate this last week. And you'll be committing a model builder. And then the sheds, which from a couple of weeks ago. So I have the watersheds here. And if I look at them in the maps, I can see then that I have basically these data displayed. Here is the watersheds. The net rainfall you can see with the heavy rainfall at the edge and the trees that reduce that net rainfall. And they're shown here with the over canopy value, and it's reduced depending on the canopy. And I have under that the surface absorption, the maximum surface absorption, and these are 9.375 times 10 to the minus 3, so that's 0.0093. Those are in the realm of what you expect, and there's zero absorption. You can see for the buildings and the hard surfaces, roads and sidewalks and such. And then I have the sheds, the watersheds here, and in my case they're numbered 1 for the northern and 3 for the southern, just as identifiers, because that's what came out of the processing, the way I processed it. So in my model here, with the net rainfall and the surface absorption, I do our simple mass balance. Actually, it shows there when I hover over it, but I'm doing the net rainfall minus the surface absorption. So everything that can get absorbed is getting absorbed. Where there's zero absorption here, the net rainfall will remain at that value and it's subtracted. Now, sometimes the surface absorption can be greater than the net rainfall, and so I have to, in this potential runoff, change that so that I make sure I have no negative values, and use this conditional function. And the way the conditional function works is that if this evaluates to true, do the first thing, assign the first thing. If it evaluates to false, assign the second. So if the potential runoff is less than 0 for this pot runoff data layer, cell by cell, so if it's a negative value, substitute 0, there's 0 runoff. We can't have negative runoff. We make that 0 runoff. That just means that the net rainfall is less than the capacity of the surface to absorb it. And if it's 0 or greater, just give it what the potential runoff was, what we measured, what was left over. And that goes into this runoff output raster. So finally then there's this zonal statistics as a table, and I need to basically input the sheds, which are our zones, and the runoff, what I'm going to calculate the statistics on, and then I'll output that to a table. And so if we take a look at this by opening it, you can see that the zonal statistics at a table takes the input, which is this shed. The value field is basically, since it's a raster, the values, and this will also run, or something similar to it, on tables that have multiple entries. We haven't gone over those are in common, but we're picking the value field here is just the value, which is that value held in the runoff. The input raster is our runoff raster, and then the output table is going to be this zonal st sheds 1 that gets written to wherever my default is. And there are many statistics types. Now I'm going to go with the sum. The reason I get away with the sum is we're trying to calculate volumes that are the cubic meters, and we have our depths measured in meters, and our cells are square meters. If that wasn't the case, if our cells were different than square meters, or if our units weren't meters, we would have to, after this, multiply by a factor to adjust to get it to cubic meters. But as I can see, if I go to my inputs here and look at their properties, it's off the screen, but at the bottom, and then I look at the source, their meter units, the vertical units, and horizontal units, and the cell size is 1 for the X and Y. So since I have 1 by 1 square meter cells and I multiply it by the depth, the cell times the depth is the number of cubic meters, so the value is actually the cubic meters. If it were 2 by 2 cells, then it would be 4 times the cubic meters, because it would be 2 by 2 or 4 square meters times whatever the depth. So I'd have to sum and then multiply by 4. But in this case, since I had that 1 square meter, I can just go ahead and use this zonal statistics table. Now I validated this, I'll go ahead and run it, and it'll take a minute here. And when it's finished, it creates then a table, and the table shows up in my scratch database. I should go ahead and refresh it. And so here's this zonal statistics as a shed. And if I look at that, so I'll double click, I'll right click and open. I then display the table, and it shows that for value 1, that northern watershed, there was 1,595.1 cubic meters, and for that southern watershed, 1,021.02. Now, your values might be a little different than that depending upon processing, but they should be pretty close to these values. So these zonal statistics functions allow you to do aggregation in one layer by zones defined in another layer.